Hey everyone, it is around 2 o'clock in the night and we are up for learning what is duck typing in Python. So before learning what is duck typing, let us understand why is duck typing needed and what type of problem does duck typing solve. So let us take 2 minutes understanding what is written in the code snippet here. First we have a class named class Stripe account which has a method name pay using Stripe accepts two parameters self and amount and does some logic implements some logic facilitating the transfer of amount from the user's account using the Stripe gateway. Similarly, we implement the same feature for the Razor Pay gateway. We have a class named Razor account. It has a method name charge Razor Pay accepts same two arguments self and amount. Does some logic implementing the payment, transferring the payment. Then similarly, we have for, same thing for the Paytm gateway. Class Paytm account having method pay with Paytm accepting same parameters self and amount, implementing the logic for payment in Paytm gateway. Now we have a method named process payment which accepts a account parameter and amount parameter. Account parameter is nothing, it expects there to be any instance of any of these three classes. And amount is an integer value which represents the amount the user wants to transfer. First, we check if this account instance is an instance of Stripe account class. If it is an instance of the Stripe account class, then we simply call the account.pay using Stripe method and pass this amount parameter here. Similarly, we implement the same thing to check for Razorpay account. If this instance is a Razorpay account, if it is a Razorpay account instance, we call the charge Razorpay. The charge Razorpay method we implemented here, we call that here. Or else, if it is an instance of Paytm account, then we call this account.paytm pay with Paytm. And if any of this, all of these three aren't true, then we execute this else block, which just raises a value error calling raising unknown payment method, which tells us that the instance passed here doesn't match any of these three in class instances. So what is the problem here? The very big problem here is this code is very ugly, which makes it very hard to read. If anyone in your team tries to read this code and understand, they will have a hard time understanding this, which makes it not scalable. If in future we try to add any classes, new features here, we will have to add one more elif statement here, which for each new feature we add, with each new feature we add, each new class we add, we have to keep adding new elif checks, which makes the code very ugly and which ultimately breaks the open closed principle. Now, what is open closed principle? Open closed principle is a design principle which states that your code must be open for extension, means adding new features to extension, but must be closed for modulation or modify. Your code must not every time be modified. It should be open only for extension. How do we solve this? And how do we write this in a more cleaner and more Pythonic way? The the correct way to implement the same logic is using duck typing. The example you see here is an example of implementation of duck typing. We have the same class name Stripe account, Razor account, and Paytm account. The only difference here is the pay. We rename the methods to pay, having same parameters here also, and the same method here process payment with two parameters, account and amount. This account is here also an instance of the any it can be an instance of any of these three classes. It also similarly in the previous example it accepts a amount parameter, which is the amount the user wants to transfer. We simply take the instance and just call the pay. If this account is an instance of this type account, this pay method gets called. If this account is an instance of this razor account, then this pay method is called. If it is a instance of Paytm account, then this method is called. So here we can see that we don't have to always check for which classes instance is it. We just only call this pay method. Now moving ahead to the definition of duck typing. So the official duck typing definition mentions duck typing is a type system which is based on a principle that states if it walks like a duck and quacks like a duck, it must be a duck. It means that an object can be replaced by another object of different type if both have the same attributes and behaviors. So we can understand it in this way that if it quacks, like if it does the job, if I want that any particular object must have this particular method, and if it does exist, I don't need to check what type of object is it. I only want that it must have that method which I need. To understand this in a more better way, we take a real world example. Like I want to put a nail in the wall. I can use a hammer. I can use a hammer to put that nail in the wall. But I can use a stone also or anything heavy to only get that nail into the wall. I am just concerned with what that tool can do, not what type of tool it is. In this example below, I am just concerned that this account instance is does the page of. I'm not concerned that if it is a Stripe account instance or it is a Razer account instance or is it a Paytm or a Google Pay account instance. I'm just concerned with this pay method. I am only concerned that it should do my pay method. So our first pro of duck typing is flexibility. Just now you saw that uh, how we so just now you saw how we use this, how much flexible this process payment method is. We didn't have to uh, we didn't have to check for what type of instance this account is. This can be instance of any classes, and it will run without any problem, without any error, until and unless this account instance has a pay method. If it does not have a pay method, then it raises a error. Next, the second the second pro we have simplicity. Like implementing something similar like this, to implement something similar to this, we can use inheritance by implementing to have something like this. We can use inheritance by abstract base classes, but that would be too much for this simple thing. So duck typing helps me keeping things simple. For the first con, we have runtime errors. There may be cases when you wrote a method like this, process payment, and run account.pay amount, and you write a new class. You write a new class that like class phone pay account, and you forget to write a write this pay method for it, or give it give or write a pay method but give it a different name. Then what happens? You save the program without any problems. But when the code runs, and in this account instance, a phone pay account instance is passed, and there is no pay method in that phone pay account instance, and you get a attribute error. Now there is a way to fix this. For example, we have a duck class. We have two methods, fly and swim. Again, we have a pigeon class which only has a method fly in it. We make a list out of the instances of both the classes. We run a for loop for birding birds, and for each bird we run this dot fly method. Till here there is no problem. We get duck is flying and pigeon is flying printed in our console. But next, when we try to do bird.swim for all the birds in this list, first we get a duck is swimming, but in the next line we get a attribute error because this pigeon class instance doesn't has a swim method defined in it. That's why we get an attribute error. To fix this, we have got some methods, and we use a coding principle kind of thing which is known as EAFP. What is EAFP? EAFP stands for easier to ask forgiveness than permission. It is a Pythonic coding style where you directly attempt an operation and then use try except blocks to handle potential errors rather than checking conditional beforehand. Like uh, like in this example, we have implemented that EAFP for each bird in birds. Try bird.swim. If this bird.swim is available, there has this bird instance has got swim method, it gets executed, and if it does not execute, it raises an error, and this except block catches the error and lets that error let this program fail silently by this pass method. Or we can do this if has attribute, if this bird instance has got this swim attribute, then only run this bird dot swim attribute. But this again violates my duck typing. We are checking for this typing, we are checking for this type, which breaks the definition of duck typing. Many people many people in the Python community try to avoid this thing because of because they like flexibility. Python is known for its flexibility. Moving on to the next one, we have lack of explicitness. To understand this, we have an example here. Like in your code, anywhere you wrote this line, wrote this thing, and wrote this thing. In future, any team member of yours tries to read this, and he doesn't just he doesn't understand what this item is, what this item instance does, and why has it got a calculate method. What is this? He doesn't know what this is. Too vague. This is too vague to understand. That's a problem that we have got in this duck typing. For the third con, we have potential maintenance issues. In future, if I change any attribute of my instance to some other name, but it gets called here as dot calculate, your code will search for that calculate in this attribute, this instance, but it won't find any method on this instance, which will again lead to a attribute error. So this all was for the cons. Now, moving on, what are the alternatives to duck typing? There is an alternative, that is abstract using abstract base classes. Abstract base classes help you to define a abstract class with abstract methods. It already gives you a structure for your future classes. This bird class there, which has bird abstract class, which had got two abstract methods named fly and lay egg. I inherit this bird abstract class in my pigeon class and implement this fly method here named print the pigeon is fly. Again, I implement this class bat bird and implement this fly flying method here. Using abstract base classes helps me to define a structure that if we do not implement any of this method in its child classes, then while saving this, it will raise an error and it won't let you save your code. You have to implement the it you have to implement these abstract methods in your child classes. If you don't want a concrete structure, then you can use duck typing, which gives you flexibility. But in cases where you need concrete structure structure, then you use abstract base classes. So here is your final takeaway. Use duck typing when you want your code to be fast, simple, and flexible, and use abstract base classes only when you want to give your code a strict structure. So in description I will give you links of two blogs which you can read to get a more better understanding, a better deep dive into duck typing. Till then, goodbye.